In this video, I want to talk to you about setting up virtual environments for your Python data science. If you're going to use Python for data science, do not use the Python that comes installed on your system or one that you install from python.org. You absolutely have to do that, but those are what I'm going to refer to as your base installations, and you never want to mess around with them. You don't want to add packages to those base environments, the base installations or installation of Python. Instead, you want to use virtual environments. Those are copies of Python, and in those separate copies, you can add all the packages that you want for that specific project. Now, there's two ways to go about it. You can install system-wide environments using something like the miniconda. I'm going to show you how to install that and create virtual environments, virtual copies of Python, and you can use those system-wide. The other way is to have it per project. Now, my projects live inside of folders on my computer's internal drive, and you would have to create that virtual copy inside of each one of those folders. Now, there are two ways to go about that. The brand new way is using the UV package manager. I'll show you how to install that. But then for every folder that contains your project or whatever your workflow is, you'd have to create a brand new virtual environment. The other way is just the normal way that we used to do it in Python, just with Python's built-in virtual environment. And I'm going to show you how to do that in Visual Studio Code. Our first installation is going to be system-wide installations. In other words, what I mentioned before is that we install virtual environments that we can use in multiple projects. And the best way to go about that, I think, is using miniconda. So when you open any search page, you can just search for installing miniconda. This is going to bring you to the Anaconda official page here for installing miniconda. And if we scroll down a little bit, we'll see install for Windows, Mac OS, and Linux, and how to verify your installation. So if you just open these little boxes, specifically for Windows, it takes a little bit more work, but you can see the instructions. What I would do is to go to this little button here. It says Command Prompt. If you click on there is some code that you can copy and paste right into your command prompt. So if you hit your start button on Windows and you search for command prompt, it's going to open a type of terminal for you, and you can copy and paste just this code right in there and hit the enter key. If we look at Mac OS or Linux, we see it's exactly the same thing. I'm not going to go for the graphical installer. I want to go for the terminal installer. And once again, you can see you're going to open your terminal and you're just going to copy and paste. So I'll show you how that works. I'm just going to go across here. I'm going to hit copy, and I've opened my terminal. This is what it looks like. The command prompt on Windows looks very similar. And this is where I'm just going to paste that command that I've just copied. And you can see there curl, and then the flag, and then HTTPS, etc. You're just going to hit enter or return, and the installation is going to take place. Now, I've already done that, so I'm just going to close this terminal. So now that it's installed, let's see what it looks like. I'm going to reopen my terminal, and you might have noticed when I opened it before, there's a word there, it says base. That base did not exist until you installed miniconda. That base is just telling this terminal that you are using the base installation of Python on your system. So I'm opening a terminal. It has nothing to do with Python, but because I have miniconda installed, all my terminals now are going to have this base in it. That little word there inside of parentheses is going to tell me which of the environments I'm using, and the base is the base installation of Python. So if you go to python.org and you install one of the versions of Python, that's the system-wide Python that this base refers to. Now, you've got to be careful on a Windows machine. On a Windows machine, if you just open your command prompt, you won't see that. What you would see is if you go in your start menu and you look under the A for Anaconda, if you twirl that open, you are going to see an Anaconda prompt. So instead of using your command prompt, from now on, you would have to use your Anaconda prompt. So just go search for it. It will be in your start menu. And when you start the Anaconda prompt, you will also see that word base there. And it's just telling our system, in case you are using Python, it is the system-wide base installation of Python that is going to be used. Now, it is not what we use in data science. That base installation, we never want to touch that. Instead, we want to create virtual copies of that. We're going to create these virtual environments, and we're going to work in them. So let's see how to go about that. And to go about that is right inside of the terminal here on Mac OS and Linux. But remember your Anaconda prompt in Windows. We are going to write some commands. So the first one is conda. It's always going to start with conda. And then a space. And then we're going to say create. That's the keyword for creating an environment. The next thing we want to do is to use a flag. Now, flag is something that starts with a minus symbol, and my flag now is going to be N and a space. Just to show you, that's just a shortcut for a proper flag, which would be 2 dashes and the whole word, name. But that, takes a long time to do, so let's just do 1 dash and N. That's a flag, and it says whatever follows this is going to be the name of the environment. And I'm just going to call my environment test, and I'm going to use the underscore environment. As long as there's no illegal characters. Illegal characters would be all sorts of funny symbols and spaces. Spaces are the worst. So just one word would suffice, and if it is more than one word, just use what we call snake case. You're snaking these words together by an underscore. And the next thing I want to say is what version of Python I want to use. So that doesn't require a flag. You can just say Python equals, don't put any spaces there, and I'm going to say version 3.13. So that's not the newest version, but I always like to stay one version behind, just for compatibility's sake. Many packages are designed specifically for a version of Python, and you might get some package conflicts or some dependency nightmares, and we can get into those at a later date. So Python 3.13, so that's good enough for me. I can hit enter or return. Another little flag I just want to show you is -- yes, or then the shorter version of that would just be a single minus and a yes. That means it won't, it'll automatically say yes to all the installations. You don't have to do it manually, but I'm going to remove that now just so that you can see what is going to come up. Now, because I've installed conda environments before, it's going to already accept those terms. I've accepted them the first time. The first time that you run a conda create command, it is going to ask of you whether you accept these terms and conditions. I think it says A for accept, something like that. Just read that and just accept those terms. Once you've accepted them once, they'll always be accepted. You'll see a bunch of information, and then it'll say the following new packages will be installed in this new environment that you're creating. And you see there, proceed, yes or no. You just have to say lowercase y for yes. But if I use that flag, -y, you wouldn't have had to do this. It would have been done for you. So I'm just going to say enter or return. And that's it. My environment now exists. It gives you a little teaser there. It says if you want to activate this environment, you should say conda activate test environment. So another set of keywords that you have to learn. So let's just do that. I'm going to say conda activate test environment. And look what happens. If you look very closely, you'll see it went from base to test environment. My terminal now knows that I'm in the test environment. That is a virtual environment that's made a copy of Python within this environment. And I can now, let's say in inverted commas, mess around with this installation of Python. I can add a bunch of packages. I don't care if I break something because I can always create a new environment. And my base Python is left pristine, untouched, and nothing can go wrong there. Now, if I'm inside an environment, I want to add some packages to Python. That's the beauty of Python. Thousands and thousands and thousands of developers have created packages that extend the usefulness of Python, or extends what Python can do and what you can do with Python. That's the beauty of it all. And so if I'm in this environment, I want to install some packages. And the way that we're going to go about that is to say conda install. And let's install a very important package, NumPy for numerical Python. Let's also install SciPy for scientific Python. Now you can see there's no commas in between. It's just a simple space. So conda install. But do remember, have a look at the front here, right at the beginning. It says test underscore environment. Make sure that you are in that environment before you install any packages. Do not install any packages while you are in your base environment. So I'm just going to hit return or enter. Once again, you can use the -y flag, and then this will be done for you, but simple enough. I'll just put a Y down and hit return or enter. And that's it. Those packages are installed in this environment. Now, to get out of this environment, I'm going to say conda deactivate. You don't put the name. It's already got the name. It knows it's in test underscore environment, so I don't have to say that. All I have to say is conda deactivate. And now you can see we are back at the base. So one way that you can look at all these virtual environments that you've created, because on my machine I've got a few, so I'm going to say conda env for environment and list. So list all the environments that are on my system. And if I do that, you can see I have the base installation there. But look at these environments and look how I've named them. So I've called this first one data science underscore python 3 underscore 13. that tells me, I'm going to put packages inside of this environment when I do data science. And I know whenever I create a Jupyter notebook and it's all about data science, I'm going to use my data science environment because I've put specific packages inside of that environment. I've also got a data science Python 3_14. So when I created this environment, I said conda create -n, then the name data science _Python 3_14. But then I said Python equals 3.14. I've got a geodata science 3.13, a geodata science 3.14, and I've got a mathematics 3_13. I've also got a Sage environment, and then the test _environment. Look, it's right there. So think of it this way. Using miniconda as this ability to create these environments into which you're going to put specific packages specific to the stacks that you're busy with. So if I'm busy with data science, I'm going to use my data science environment because I know I said conda install, and all the packages that I would require for data science, they're going to live inside of that environment. If I'm doing geodata science or geospatial data science, I've got a bunch of geospatial packages, data science packages inside of that environment. And if I'm just doing mathematics, I'm going to use my mathematics environment. I know I've put lots of packages such as SymPy, that's symbolic Python, NetworkX for all your network analysis, your graph theory, etc. So that's one way to work. And I like to work this way because I only have to have these couple of environments and I can use them over and over again. So that's one way that we can go about it. Remember, I said the second way to go about this is to create an environment for each and every project that you're working on. And that's great if you are going to share your work with someone else and you want everything to be self-contained. The problem that I do have with this is that it creates many instances of Python over and over and over again. You're installing so many things over and over again because it has to be done for each and every project. Now, the way that I would go about that is for each of my projects, I have a folder on my computer's internal drive. So if it's a research project, it's going to be a folder in my documents folder. If it's some educational content that I'm working on, it's going to be a folder on my computer's internal drive. Be very careful though for these next steps, specifically in Windows. Do not put your folders inside of cloud services such as OneDrive. Sometimes it's difficult in Windows to know whether you're saving a file on your internal hard drive only or whether you're saving it on an internal hard drive but on a OneDrive accessible folder, so all these things go to OneDrive. The virtual environments and OneDrive do not always work together. So if you are going to do folders and the steps that we're going to see next, make sure that it's folders that are local to your system, not in OneDrive or some cloud service. And that actually goes for all cloud services when it comes to these virtual environments that I'm going to show you next. So the next virtual environment we're going to talk about is UV. UV is brand new. It's written in Rust. And the whole idea, the Rust language, the whole idea is that it's exceedingly fast. So when you install things, it's just going to be very rapid. You can search for Python UV, and this is the GitHub repository where the code lives. And you can see it's astral.sh and then /UV. So that's the UV environment of this account called astral-sh. If we scroll down, you can see there a single tool to replace all your other installation tools. It's 10 to 100 times faster than pip. You can see all the highlights there. Now you can click on these links and it'll take you to the actual documentation pages. There are 3 of them that I want to highlight. This first one is just the installation page. So you can see it's docs.astral.sh. And there's an installation page here. And there you go. You got macOS and Linux. And once again, as you've seen before, it's opening your terminal, copying and pasting this command right here. When you go to Windows, it's a little bit different. And this is what you should type in. Now you can type this into your command prompt. So this is very separate from Anaconda or Miniconda, so you don't have to worry about that. But there is your installation. I would really read this carefully. It's a bit more involved to get this installed on a Windows machine, but certainly in macOS and Linux is very simple. You're going to copy and paste that command, and it's going to install UV on your system. The next page I want to show you is just a little bit further down. It's to how to install Python once you've created one of these virtual environments. And there you go, UV install Python install, or UV Python install the specific versions. Now see how this is different from what we did with the conda keywords. Here it's UV Python install 3.12. There's no equal symbol. It's not Python equals 3.12 or 3.13. You can also install more than one version at a time. So there's a lot for you to read here. But what you do with the installation is you're going to go here to installation right there. You're going to copy and paste the appropriate line of code, and you're going to pop that into your terminal or command prompt. Once you're in there, you can install specific versions of Python. And the final page I want to show you is working with projects. So that's a little further down, working on projects. And this is 2 ways that you can go about doing this. There is the first way, and here is the second way to go about it. Let's do this first one. So what I'm going to do, I'm going to open my terminal once again. Okay, you can see I'm in my base directory. It's got nothing whatsoever to do with Conda, so we can just ignore that. I think it's safe just to be in your base environment anyway. Now, a couple of commands. If you want to see what folder you are in at the moment, the Windows command is dir for directory, but on Mac OS and Linux, it's just ls for list. And if I look at that, I can see I'm in my home folder at the moment, and I can see the subfolders: applications, documents, library, music, public, pictures, movies, downloads, etc., desktop. That's the way that you can navigate. So I want to navigate to my documents folder, and the way I'm going to do that is type cd, that stands for change directory, space, and I'm going to start typing DOCU. I've written enough unique letters there. If I hit the tab key, it's going to do auto completion for me. I'm going to hit return or enter. That's it. Now I'm in my documents folder, because it's right here in my documents folder that I want to create a new folder that's going to serve as some research project, for instance. So let me just move this out of the way ever so slightly so we can see what we have to do. You can see the UV init and then whatever the name of your folder is going to be. So I'm in my documents. I'm not inside of a folder. I'm creating a folder with what I'm going to do now. I'm going to say UV. Now do remember my UV is already installed. So you've got to go through that process of copying and pasting into your terminal command prompt what we see under the installation page here for UV. That's already done. So I'm going to say UV init, short for initialize. And I'm going to say this is going to be, let's give it some research projects. Let's say it's going to be something like gallbladder research. That's going to be the name of my folder. I'm giving it a very descriptive thing. I'm busy creating a research project about gallbladders. It's a safe name to use. So I'm going to hit return or enter. And then it says it's initialized this object called gallbladder research, and it's inside of this folder, which means I can change into that folder right away. I'm going to say cd, and I'm going to go to this gallbladder. And again, I just hit tab. And now you can see I'm in that folder. It's a folder that exists in my documents folder or my documents folder. And now I can just use it. Now what I want to do is to install a version of Python here. Before we do that, let's do a sneaky ls just to see what's in there. And you see there's a main.py file inside of this folder, a pyproject.toml toml file, and a readme.md file. Because this is rough and ready for you to use GitHub. Now, I'm not going to talk about GitHub right now, but your project, it's completely possible just to push it to your GitHub account. If I go to installing Python right now, let's do that. UV install, UV Python install, and let's do 3.13. You see it was downloaded and was installed, and that was so quick. It's much quicker than Conda. But do remember, you would have to do this for each and every research folder or any kind of content that you're creating. That goes in a new folder, and you'll have to do this UV install over and over and over again. You can see how that is different from just having those couple of virtual environments, and you're going to use them over and over again. Now, the next thing that I want to do, I want to add some packages. Remember, we installed NumPy and SciPy into our virtual environment when it came to miniconda. I want to do the same thing here. So I'm going to say UV, and here we don't say install, but we say add. So UV add, and let's add NumPy, and let's add SciPy as well. And that was very quick, and it's done. And we can see we have NumPy version 2.4.1, and SciPy we have version 1.17.0. That was very, very quick. Now, I want to use this virtual environment inside of Visual Studio Code. So what I want to add is an IPython kernel. So what I'm going to do is I'm going to say, this is what I do for every project, by the way. So it's going to be UV add, but I'm going to make this a dev, double dashes, dev for development, IPyKernel. So what that's going to do is just going to install it here locally. When I share it with someone else, this package is not going to be there. It's not going to be available. inside of this list of all the packages that go in here. Now, you don't have to do that as a dev. You can just do ipykernel. This is just the way that I go about it. So every one of these virtual environments with UV, I will install ipykernel. And look at that, it was so quick. I'm just going to hit the up arrow key because there's usually one I do add, and that's the old-fashioned pip. And that's it. Now you can add all the packages you want, particular to this project that you're working on. You know that you might want to use some statistical models. Maybe you want to install the stats model package. Maybe you're going to create some plots. I'll install matplotlib. So UV add matplotlib. That's where you're going to add all of these packages. And so that is as far as I'm going to go with UV. So UV is about creating a folder on your computer's hard drive. Please remember, don't do that in OneDrive or some cloud service on your internal drive. I want that locally on my machine only. And this UV is going to create the folder for me and put all the stuff requiring, the Python's going to require right inside of that folder. But I'd have to do that over and over and over again. That is compared to using Anaconda or the miniconda then, that uses the terminal, the command prompt, or then remember in the Windows, you'll have to use the Anaconda prompt to create those separate virtual environments that you can use over and over and over again. Now that we've done this, let's go to Visual Studio Code and see the third way, and then also how we might use either this UV environment that we've created or how to use one of our miniconda environments. So here I'm inside of my Visual Studio Code. I'm right at the top with the Explorer window that's open on the left hand. The Explorer pane is open on the left-hand side. And let's see what we can do with this. The first thing that I want to do is just to use that folder that we just created with the UV project inside of it. So what I'm going to do, I'm going to open my Finder or Explorer, and I'm just going to drag it right into that empty space. Or you could just have used that button that said open folder and navigate to that folder. But look at this. They're the files that we've seen before, the main.py, the pyproject.toml, the readme.md file. But you can see there's also a bunch of hidden files. There's a .venv folder there. That's virtual environment. If I open that up, you can see there are all the binaries in there. That's where the Python that I installed. And that is where all the packages that I installed would live. The NumPy, the SciPy, whatever packages. That's all there, so it creates this virtual copy of these things here. And once again, it's not touching my base installation of Python, which I never ever want to do. Let's close that up again. And I'm just going to create a brand new Jupyter notebook. I'm going to hover over this little button right at the top. It says new file. I'm just going to call this test.ipynb. It's got to be an IPython notebook file, so the extension has to be ipynb. If I hit that, I see I have a brand new file, empty file open. It's a Jupyter notebook, and I go right to the top there on the right-hand side, and I say select kernel. And what do I want? Well, I'm going to have quite a few of these. You might have fewer ones. I've installed a lot of other things as well. But I'm going to go to Python environments, and right there with a little star, look at that. Gallbladder Research, Python 3.13.9. It lives inside of this venv bin Python folder. That's the one that I want. But look further down. There's my data science, geodata science, mathematics, Sage, the test environment that we created. They are all there. They are going to be recognized here inside of Visual Studio Code, those miniconda installations of Python. And that is what I'd like to use because I can use them over and over and over again as opposed to recreating a virtual environment in every folder. I think by now you can see the difference between those two, but I wanted to show you here the UV environment that we created. So I'm just going to click on Gallbladder Research, and now Python is available here. If I create a new code cell and I would say 2 + 2, hit Shift Enter, it says 4, the code is running, no problem. Remember with Jupyter Notebooks in Visual Studio Code, when you see that little round black dot there, it means this file is not saved. As soon as I hold down Command and hit S or Control and S, it gets saved and now changes to the normal closing that tab sort of button. And that's it. I can export this whole folder to someone else and it'll work on their system. This pyproject.toml file, it generates all the content that is required for someone to recreate this project on their system. I told you as well that GitHub is activated by default. If I look at that little button there, source control, it says all these things that are in green. Well, you haven't uploaded that to your GitHub account yet. You haven't pushed it to your account yet. And if you click on that button, you can write a little commit message there and commit this and then push this to your GitHub repo. But remember, you'll have to have GitHub set up first, and that's not what this video is about. I just want to make you aware of the fact that at least these UV environments, using UV for your environments, that is going to do that for you. You can see your README file. That's going to be the README file in your GitHub repo. So this would be one way to go about it, but do remember, you've already seen the second way. When you start a new blank folder, for instance, or open one of the folders in your computer, and you start a new Jupyter notebook here, when you go to select the kernel, all your miniconda environments will be listed there for you. Good, now I want to show you the final way. I'm going to close this folder, close everything. My sequence is always File, close Editor, File, close folder, and there we go, everything is closed. So let's talk about the final way. I'm just going to bring in a folder. I'm just going to drag from my Finder or my Explorer. I'm just going to drag that into an empty spot, and right now I'm in that test folder. It has nothing in it whatsoever. Maybe you have some data files, some spreadsheet files, CSV files in there already. I'm just using a blank folder. I'm going to click on the new file button, and again I'm going to call my file test.ipynb so that it is a Python notebook, and I'm going to go for select kernel. I'm going to select Python environments, but now right inside of Visual Studio Code you can create an environment right here. See there, the first was create Python environment. Look at, there's all my other Python versions there. I'm not going to see the gallbladder one because that was a UV environment specific to that gallbladder folder. So you won't see that now. I'm going to click on Create Python Environment. And now it says, do you want to use Conda? And you can create an environment with Conda. Now I'm going to imagine you are not going the Conda way. If you did not install miniconda, you won't see Conda there. All you'll see is this first one, venv. That's the built-in Python virtual environment system. And your Visual Studio Code is going to recognize this and give you the ability to set up your own virtual environment inside of this folder. So this suffers from the same problem of as UV suffers from, that you have to create these virtual copies in every folder that you're working on. So I'm just going to click on that first one, virtual environment. And then it says, well, on my system, it's found these base installations. Now you saw base when I opened either my Anaconda prompt version of terminal on Windows or my terminal on macOS and Linux. You just saw it said base. It was using my base Python installation, but actually I have 3 different versions of Python installed on my system. If you go to python.org, you can install all sorts of older versions of Python. So on my system, my base Python systems, the ones that I never want to add any packages to or never want to change, these are the ones that are going to be listed here. I don't want to mess with them. I want to make a virtual copy of them. So let's select 3.13.9. It is on my system. So if you don't have any Python's on your system, remember, go to python.org and install 3.14, which is the newest one as of the time of this recording. They are working on 3.15, so you'll also see that on the web page, but you can do 3.12 or even older. You see I've got a 3.9.6. This 3.9.6, by the way, I think that comes with your version of macOS. So I'm going to choose this one, 3.13.9, and now all sorts of things are going to pop up here. The first one is, we noticed a new environment has been created. Do you want to select this for this the workspace folder? I'm going to say yes. Now this output, I've got multiple Python interpreters. That's a different story. We don't have to worry about that. I'm just going to close that for now. But look at the top there. A .venv was created for me. If I open it up, it looks exactly the same as the stuff we did in UV. Now that's what UV is actually doing, but it's not using this older version of creating this through Python's virtual environment system. It's a brand new piece of software written in the Rust language, as I say, for this performance that we've seen there. But in essence, they're trying to create the same thing. So you're not seeing any TOML files here. You are also not seeing the rest of those GitHub files that we've created before. But whatever I need to do is right there. So now I can use Python inside of this notebook. So if I say select kernel again, Python, I'm going to then select this virtual environment with a star now. So I've already created it, it exists, but I've got to tell this notebook which one to use. Well, this one that we've just created. Thank you very much. And there you go. These are the 3 ways to install virtual environments on your system. When you're doing data science work, never ever work in your base installation. Never install anything in your base installation. Create virtual environments. Your 2 choices: create the system-wide ones using miniconda, which is my preferred way, or use either UV or this built-in Python environment system, virtual environment system, for per project or on a per folder basis. It is very convenient to use it this way, specifically if you want to share it, but I find that it does create, it takes up a lot of space on my internal drive because you're just recreating these copies over and over and over again. But depends on your workflow. Now you know how to set up virtual environments in Python.